some of the details from the earlier session, so my apologies if you've seen that part already.
네, 지난번 세션에서 이제 강의했던 내용을 간단하게 요약하도록 하겠습니다.
Now, traditional workflow for bringing CAD data into Unreal Engine has always relied on Max or Maya as a middle step, so one that required you to do extra work to get there.
네, 그래서 기존에 CAD에서 언리얼로 이것을 옮기려고 하면은 넥스 그리고 마야를 거쳐야 했습니다. 그래서 추가적인 작업이 필요로 했다라는 것인데요.
So what that results in is people having to manually merge objects, reduce polygon count, and add light map UVs, as well as defining their own LODs. Now, what we're doing now is this. Thank you. So that pipeline has always relied on FBX. However, this itself is a problem. Now, it's a problem because it's time-consuming, it's destructive, it's hard to iterate on. It requires experience in CAD and Unreal, which is a higher specialty. It loses information in translation, such as materials, lights, and camera translations. It's also expensive. Now, it's expensive in terms of a people standpoint, time standpoint, a specialty standpoint, and from just the iterations. Epic Games have introduced Unreal Studio. Now, Unreal Studio is in free beta at the moment, and it will continue to be free until we leave beta. Now, Unreal Studio includes Datasmith, advanced support for enterprise-specific customers, video tutorials, and advanced enterprise-specific documentation. So the idea here is to kind of create an addition to Unreal Engine that allows enterprise customers to have enterprise-specific problems treated as they should. Now, there's already quite a few customers on board with this. However, it's continuously growing. And it's resulted in some real improvements to the Unreal Engine pipeline. And a big one of those is called Datasmith. Now Datasmith relies on your existing pipeline, so your CAD data and everything else being created as you work, except now, instead of an intermediary step, what we have is Unreal Engine handling the cleanup and the importation for everything that you previously had to go through. So this means that we now have support for 20 plus CAD formats, including metadata. We have tessellation controls. We have Python integration for scene assembly and optimization. It also allows for repeatable processes. We have automatic UVs generated for light map generation. And as well as that, we have a VR and desktop viewer template, and we're looking at expanding on that too. Now, included with Unreal Studio is a product viewer template. This supports both desktop products and HMD products. So that means that you can view it in VR, or you can view it on your desktop just out of the box with all of the functionality there. Now, to do that, all you need to do is run Unreal Studio and create a VR template, as you can see just here. Now, one thing that's worth noting is when you do this, if you want any actors in your scene to be movable, you're going to need to set them to movable still. So you'll need to still dictate to the product template what is pick-upable and what is not. So, amusingly enough, the import pipeline for CAD is literally one of clicking import CAD. Now, when you import CAD, it's going to give you all of your options for STL and CAD data and all of the other formats. And it's going to give you a couple of options for you to choose what's necessary to bring it in. So for this, we have static mesh options, which is setting the minimum and maximum light map resolutions. We also have geometry and tessellation options. So the geometry and tessellation options control just how fine-grained and how high poly the meshes will be once they're brought in. So this will control the automatic initial level of detail that you'll be working from. Now, the chord tolerance sets the maximum distance between a generated triangle and the original surface. So what that means is if we had a curve and we were rendering polygons along it, if this polygon was going to be too far away from the line, it will then splice in a new one. So that tolerance controls how likely it is to add one there. Now the maximum edge length controls the length of any edge of a generated triangle. Now all of these are measured in metric, and it's one of the main reasons that it's important that when you're importing into this, that your initial CAD data was correctly set up in the metric method. Finally, normal tolerance sets the maximum angle between any adjacent triangle. So if this triangle was going to be here, it'll splice in a new one to curve out the surface to make sure that curves stay consistent. Now, this isn't an instantaneous process. When you bring it in, you will need to wait because it needs to process your entire CAD setup and every mesh and model that is there. But it'll still be quicker than having an intern go through it, that's for sure. So it can take time, and it really depends upon the speed of your computer and the complexity of the meshes, as well as the number of objects in your scene. But ultimately, if you're importing from CAD without any materials, you immediately get the ability to just grab anything, reach out with a hand, pick things up, and move them around. So from the get-go, you then have the ability to have VR support as you go along. So for this, we obviously this gets you into the engine. But how do we set things up here? So the first feature I'm going to touch on is one called Blutilities. Now, Blutilities are a lesser-known feature in Unreal Engine. It's a blueprint utility. Now, these have been experimental in the engine for quite a long time. So what a Blutility is an editor-only blueprint that you can use to perform editor actions and add your own quick scripts. So if this was the asset, this is the asset as we import. And you can see on the right that it has the asset hierarchy as well. I forgot to name things ahead of time. But what we see here is that if I select the wheel, I'm selecting just the tire right now. Okay? Now, if I go into my editor preferences, into experimental, and enable Blutilities, what I'm able to do is go through, and I'm now able to create a Blutility class by right-clicking, selecting Blutility, and basing it on Global Editor Utility Base. Now when I do that, it's going to create a new Blutility asset that I'm going to have to right-click on and select Edit Blueprint. And what you're able to do here is create any function that is now going to run in the editor. So it's not something you add to the world, it's actually just an editor script. And one of the important aspects here that you need to be aware of is the call in editor button up here. That call in editor button needs to be checked, okay? And if it's checked, see down here, test function and other test function. These two events can now be called in the Blutility. So if I double click on the asset that we had in the content browser, it will open up this window and give me buttons that I can use to just perform scripts. So you can also set variables to be editable, and you can fill them in so that the script will correctly process this information. Okay? And what that means is we can start having some really powerful functionality. For instance, if my script said, get every actor in the world, see which one has a specific name, there we go. See which one has a specific name, and if it matches the name, or at least part of it matches the name, join them into a single static mesh, we can then see that we're able to combine that entire bike into a single model. Okay? Now, obviously, this is a very basic demonstration of that, but let's look at some other things. For instance, in this scenario, what if we were to get all of the actors and we were to look at all of the materials on the actors in the world? And anytime they had a material here, we set them to a material that's referenced here. This way I can remap certain materials in certain situations and run my own custom scripts to handle logic for setting up my scene. Now these quick scripts are incredibly powerful because it lets you kind of open things up. It lets you set them up such that you can easily modify the content as you see fit. And it's one of the reasons that it's very important that Datasmith actually includes all of that information and all of the hierarchy information and metadata information when we import everything over. Because unlike importing something from Max or importing something from Maya with FBX, it exposes options that we can then use within the editor to customize that content further. So we'll look at the same functionality, but this time with Python. So both Bluetilities and Python are methods of organizing content. And to enable Python, you just need to check Python Editor Script plugin in the plugins menu. And I also highly recommend enabling editor scripting utilities. Now, editor scripting utilities it enables a lot more functionality in Blueprints that most people are unaware of. It lets you load, save, rename assets in the content browser. So instead of modifying the game, we can modify the editor itself. It also opens up various utilities for saving, loading, and looking at level libraries, as well as editor functionality for filtering information that's usually only in the editor. Now, if you want to run a script from Python, there are 3 ways to do it. You can click File, Execute Python Script, and then click on the one that you need. Or you can go execute a Python script from console by simply typing in py space the name of the Python script, and that accepts arguments. And then finally, you can open up the console and change it from CMD over to Python and execute single lines of Python if you need to. So if we were to look at that same functionality, but this time done within Python, we can see here that we're opening up a data table, and then we're checking through it, and we're seeing if one thing matches the other to set it to the final. So this functionality is the exact same as this functionality. It's really just a question of what you're more comfortable using. So if you're coming from a CAD background or something similar, and you're used to Python scripts, this is very useful. Now, if you're a little concerned about getting into this, I'd highly recommend looking at the sample scripts for Unreal Studio. So these are the ones that are available by default. However, we have more in development. And as far as I'm aware, all of these are both Python and Bluetilities, so you can use either of them. And they're available from this link up here. Okay? And that's available online, so you can look that up as well. Now, if you're exporting imagery from the engine, there's a few different ways that we can go ahead and do it. First off, what we can do is we can export high-resolution screenshots. Now, high-resolution screenshots are quite easy to take, and a lot of people are unfamiliar with this functionality. If you click on this arrow just up here, and then select high-resolution screenshot, that's actually going to let you set a multiplier, so it renders the next frame in anything multiplied by the current resolution. So if you have a 2K image and you multiply by 2, you end up with a 4K image. But this is a really nice, easy way to set out with 16K images that you've just aligned from the viewport itself. Now the other feature that's here that most people are unaware of is buffer visualization targets. So if you want to, you can actually output a very high resolution pass of an existing buffer. So it's worth noting that that exists. Now, as far as CAD users are concerned, the use custom depth as mask is incredibly useful because it lets you push these images out with an alpha layer that is everything that isn't the product. So that way you can output just the motorcycle without having all of the background imagery and having to key it out in Photoshop or whatever you may be doing. Now, the other option for exporting content is Sequencer. So Sequencer is Unreal Engine's cinematics tool. It's very easy to just add down video and export these as video files. But what I think is incredibly important is, while it's easy to make a sequence, many people don't realize that you have the ability to export these, again, at any resolution you choose to. So it'll go through, and even if your project isn't running at 100 frames per second or even 5 frames per second, you can output a 30 FPS video file. It'll just take its time to render, and it'll output it at whatever resolution you choose, at whatever frame rate you choose. And it's worth noting that one of the features that's coming into 420 is the ARKit support. So in 420, the new version, you can use your iPad to film through the screen and move around the product, and then save that data as camera data for Sequencer. So you can actually just pair your machine and your iPad up and use your iPad as a camera to get those really nice angles and to get some really realistic shots straight in there. Now, one thing that happens quite often here is when you're working with CAD data, quite often you're going to be working with some pretty intricate structures. Now, if you're working on something reasonably simple, that's okay. But if you're working on something that's really, really, really complex, it's a good idea to know what you're able to do if you need to get it running in VR or if you need it to be optimized. So the first step here is to consider your requirements. It's interesting because Unreal Engine, it's quite a powerful tool, but it's really made for large, complicated worlds by default. And that means there's a lot of structures in there that are excellent for rendering huge environments. But if you're rendering a single complicated asset right in front of you, you don't need it. Like, you don't need a lot of the logic that's going on behind the scenes, because the information that says if something's behind a mountain, get rid of it, is irrelevant if you don't have a mountain. So what that means is you need to determine what's necessary for your project. So the first thing I'd like you to consider is occlusion queries. Quite simply, do you need to actually see if something is behind other things in your world? If at all times you can see your main objects, then they're never being occluded. If they're never being occluded, you don't need to check to see if they're occluded, so you can turn this off. If your scene is almost entirely movable objects, then you might want to enable movables in your early ZPass, which says don't render pixels if they're behind movable things. These are just simple things that I kind of want to point out because in hindsight they're very obvious, but a lot of people don't think about turning off features that they optimize video games, but in this kind of single static environment, they actually don't matter. So even though they're an optimization, they're actually overhead for your kinds of projects. Another good example of this is hardware clear, which you can see on this optimizations list as well. So clearing the scene means every time the computer goes to redraw the next image, it clears the image first. So by telling it to not clear the image, it's just skipping that entire step. So if you have a sky dome in your scene, you never need to clear it because you'll always be rendering a sky dome, just as an example. Now, the next thing to consider is, does it actually need to be dynamic? So if you're making an object that's movable in real life, but in the engine it's only going to be sitting there staying still, do you actually want to have that object as something that is movable? A good example of this is a car, okay? I want you to think of a sports car sitting here on the stage. Now, when we think of this as developers, we think of this as a car. We think of it as something that needs to move and drive around. Okay? But the truth is that if you're rendering a car, while it is in real life a movable object, it doesn't necessarily need to be movable in Unreal. You know, if the customer is looking at it and the car is staying put and it's staying in place, then you could theoretically just make it a static object and do a super high resolution lighting bank and make it look gorgeous. And your customer's never going to know that that's the situation. As far as they're concerned, they just see a really good looking car. And that's kind of what matters here, right? So consider whether something actually needs to be dynamic. So next up is shadows. Quite often, people enable shadow casting, and they have very complicated CAD setups where everything is casting a huge, like 50, 100, 1,000 different shadows inside of it. But the truth is that quite often you can set these objects up to be unlit and just use ambient occlusion. And if you set up ambient occlusion, it means that we're just rendering as a post-process the darkness around objects. And you'd be amazed at how often that actually looks quite good with far, far, far less overhead than if we were shadow casting across all of our objects. This is especially the case in actors with a high number of mesh components. Now, another good example here is up here. Now, I know this seems complicated, so my apologies. This is kind of one of those more advanced things that you can do, but it's an Unreal Summon, so let's do something like that. In this situation, if you look at this bush is actually unlit. Okay, so it's not running through any of the lighting calculations inside of Unreal. This is actually taken from the Zen demo, which was an example piece that was made for iOS mobile. So what we're actually doing here is we use a blueprint that exists in the engine that you can use. It's called Render to Texture Tool, and it takes an orthographic image of the bush from a given angle. Now, when it takes an orthographic image from that given angle, it actually is basically one time taking an image of the depth. And because it knows the depth, we can then use that depth information to create a shadow inside of the material by just using this node that already exists and plugging that texture in. So this functionality means that you can have what appears to be a really well-lit asset, but in reality, it's unlit and it's just low overhead. This is especially useful in VR. Now, one thing I want to bring up here as well is that because we're doing this here and we're rendering it like this, it also means that the shadows are consistent with when the image was taken. So if you imagine a machine that we've cut in half, because let's say in your CAD your demonstration here, you have the ability to create cross-section images. If you did that normally, all of the light would fill in and you would see inside of the object because there's no longer half of the machine. But if we do it this way, where we're pre-baking our lighting straight onto all of the assets, it means that when we cut the side of that object off, what we're left with is something that's consistent when we cut it open. Now that may be what you're after, it may not be what you're after, but a lot of people don't even know that that's an option. Now the next thing is material permutations. So if shader compilations are taking too long whenever you're re-importing, be aware that you can just turn most of these off. They're on by default so that everything supports all of these features. But if your project doesn't use atmospheric fog, there's no point compiling all of the materials to work with atmospheric fog. So browse through these at some point. This is one of those things you'll get more familiar with as you use Unreal more and more. Now, the next is the forward renderer. I brought this up in the previous session. The forward renderer is often looked at as something for VR. However, it's worth noting that it is incredibly powerful as a rendering tool And if you want something that has very, very, very fine anti-aliasing, this can be a really good option. Now, depending on how you're handling your pre-visualization work for assets in this situation, it may be appropriate for you, it may not be, but I would recommend at least testing it on projects and getting an understanding of the image difference between enabling it and disabling it. Because the deferred renderer handles dynamic objects very well. But if you're using a pre-baked example, like the car that I mentioned earlier, then then that's just static lighting, at which point the forward renderer might actually be the better option. Now, as far as additional things that are available to you, first off is the automotive materials. These were developed alongside McLaren for GDC 2016. Now, these are all freely available from the marketplace. So, if you go into the marketplace and type in automotive, you'll see all of these. And you can use these in your own projects. And it'll give you a good fundamental understanding of what's there, because there are a lot of different surface types there. And they created something that looked like this, and this in the engine. So these are quite high quality materials. And if you're trying to get an understanding of what's going to look good on your projects and what's not, this is a good step. Now, next up is the custom depth stencil. So the custom depth stencil allows you to render objects that have been tagged as being on the custom depth channel. Okay? So after your image is rendered, it goes through and it renders a depth pass that is purely on the objects in your scene that you've set to be custom depth. Okay. So what I mean by that is this. If we look at this image, I know it seems a little bit complicated, but bear with me. So if we look at this image here, this here represents some high quality pens. This here represents the image that you would normally see on screen, okay? And this here represents how far away every pixel currently is that we can see. And this represents how far away the custom depth assets are. Now, I bring this up because if the custom depth asset is further away than the current scene pixel, we can then create this outline effect on the bottom. So if you were doing CAD data inside of a machine, you could go ahead and just tag internal components so you could generate outlines for those specific assets. Do you get what I mean? So this would allow you to have like X-ray vision for certain assets in your scene, depending on what you wanted to show to a client. Now, another feature that's quite important is world-aligned mapping. I brought this up earlier in the architectural discussion. Essentially how this works is instead of UVing your assets, so worrying about all of the time it takes to unwrap your assets, you can project your surfaces. And when you project them, it stays consistent across them. So all of your assets with carbon fiber, for instance, could all be lined next to each other, and it would look like continuous carbon fiber running along the asset surface. And this is just a single Unreal Engine material node, so it's not particularly hard to add. It does have a bit of overhead associated with it, but it can be a very quick way of getting things up and running in your project. So next up is Convolution Bloom. Now, Convolution Bloom is typically overlooked inside of Unreal. Most people don't know that we added it, but it allows us to add shaped bloom. You can see it on the car over here. So it allows you to add nice physical shapes to your bloom. So you end up with a far more realistic camera look. This is a really nice little touch, and to do it simply requires you to select Convolution Bloom from your post-process. And that's it. But most people just don't know what's there. Now, if you're designing something as augmented reality, that often sounds like it will be quite difficult. But the truth is it's actually pretty straightforward. And there's a really simple way that you can bring augmented reality content into your projects with ease. So, I want you to imagine this. If we made a motorbike as a real size, okay, we made that motorbike at a real size in its own level, and then we opened up Unreal's AR template, which is a thing that we have in the engine by default. Instead of loading in an actor or something in AR, what you are actually able to do is load a level in at a given position and rotation. Which means that that motorbike, which is made up of hundreds of different actors, could theoretically sit in a level and get streamed in at a location. And we're able to use this world to meters scale functionality so that when we scale, when we click on something in the world, we can see how big the surface is. And if I know that the surface only supports a 10 centimeter motorbike, I can scale down the world digitally and then load the full-size motorbike onto my table, and it will act as if it's full size, and all of its camera tracks and everything will still work. But in reality, it's actually 10 centimeters. So this allows you to have very simple, very clean AR implementations that can be of any size for your, if you're at your client's desk, you can easily just stream the building in to be the size of the client's desk. If you want to demonstrate it to the client on the floor, you look at the floor and hit the button, and it will then stream the level in at the correct size. And to do this is literally 2 or 3 blueprint nodes. It's very straightforward. And most people just don't know that it's an option. So they often rebuild their content and they go through a lot of extra work that's actually just unnecessary. So it's cleaner because your content can now work in VR or AR at any scale. It allows for sequencer and multiple blueprints to be streamed in. So if when you stream in your motorbike, you also have blueprints that are highlighting certain features. They will all stay intact. And it's quite simple to do. The only issue you have when you do it is that because you're telling the engine that the world is a different size, if your motorbike is 1/10 the size, when I tell the engine to trace from my finger 10 meters, it will only trace 1 meter because it now thinks that 1 meter is 10 meters. So you need to adjust those calculations as well. But it's pretty straightforward to do. Now, next up are VR optimizations. So if you're working in VR, I highly recommend disabling depth of field, lens flares, screen space reflections, and bloom. Basically, anything that's operating in post-processing is operating across your entire screen. Now, because it's operating off your entire screen, what that means is every pixel adds extra computation. And because VR has 2 eyes at high resolution, those are even more intensive again. So limiting them quite quickly is a good move. I'd also recommend limiting translucency wherever possible. There's a nice feature inside the engine that I don't have an image of here, which allows for dithered temporal anti-aliasing. So that allows you to have seemingly transparent surfaces that are actually not really transparent. There's a good example of this in the Showdown demo, which is available in the Learn tab of the launcher. If you look at the rocket smoke in that demo, it's very, very, very efficient VR translucent. Now, next up is in VR, it's very important that you always manage your draw calls. Okay? So this is typically one of the most expensive things in VR. Because every time you render a new material or a new aspect of an actor, it's going to have to do it in a new draw call. And these very quickly add up because it has to draw it in your left eye, and then it has to draw it in your right eye. Okay? Now, there's a nice little feature inside the engine called instant stereo rendering. And this is typically how it draws your eyes. It draws the left eye, it draws the right eye, and it's done. If you enable instant stereo rendering, anything that's far away, I clicked the wrong button. Anything that's far away, anything that's far away will get rendered in a single pass, and it will use a vertex shader to move it to both eyes. So you'll see here that when it uses instant stereo rendering, it renders both eyes at once in a single draw call. Okay? This is very, very useful and it's simply a VR optimization you can enable. However, it's worth mentioning that while it cuts back on your draw calls, it does add vertex instructions. So there are some projects where it's going to be very beneficial. However, there are other projects where it could be somewhat detrimental. Now, one thing that's worth mentioning that is not enterprise is Robo Recall. So this was a game Epic made with Oculus, okay? And if you go to the modding tab of the Unreal Engine launcher, the game is freely available for you to analyze, okay? So it's a VR shooter that's in the editor. Now, I bring this up because a lot of people look at it and think to themselves, well, I'm not making a shooter, who cares? But the truth is it is a very pretty game that has been very, very well optimized. So if you're after an idea of the kind of content that can be created, and you're wondering, what you could do with ArcViz in VR and features that are there, even though you're not making a game, don't be afraid to look at this as a free resource to kind of learn and rip apart and understand a bit better to apply to your own areas. So if you're after additional help, it's worth noting that we have all new videos by professional video authors that have been being created. We currently have 30 hours of videos, but we have more coming out. In addition to that, we also have more content coming out in the way of Unreal Studio features. So at the moment, we have 100 free substances. However, this is something that we're developing further. Now, when it comes to the roadmap for CAD-related information, this is currently what's in the pipeline. This is where we're going. If you're wondering about the workflow of how things work, this is what we've got. So some of them will require an export plugin. However, others will have native support, similar to CAD. It's worth mentioning that DeltaGen, VRED, and AliasWire are coming in to Unreal, but they will only be available to custom licensees. So if you'd like to know more, you'll need to contact someone at Epic, and we can have that conversation with you. So in addition to that, we have more video tutorials, virtual camera support, which I mentioned earlier, as the ability to use an iPad for cameras. We have SketchUp support, Rhino support, virtual texturing coming in, advanced programmatic mesh creation. CAD mesh editing is a really exciting one that comes in with 420. This is going to sound very simple, but in Unreal you can now select faces. You can select faces and you can swap material IDs in the editor without exporting and re-importing. You can assign materials to selected triangles. You can flip normals on selected triangles. So generally, a bit more of the cleanup that you'd be used to can now be done in Unreal if you don't want to have to export and re-import. And finally, of course, we have cinematic depth of field coming as well in 420. Cool. That's it for me for the main section of this talk. My apologies for the issues at the very start of the session. So does anybody have any questions?